In the previous video, which was a confidence interval example, we went over this problem. So now this is a confidence interval example, additional comments. I'm just going to point out a couple quick things. So again, this problem, a study was run to estimate the proportion of California community college students who have dependent children. A random sample of 100 students was drawn. 31 students were found to have dependent children, and our job is to find the 95% confidence interval for the proportion. When it comes to confidence intervals, I have yet to find a proportion problem that does not say the word proportion or percentage in asking the estimate we're supposed to find. So at least for confidence intervals for population proportion, it should be pretty clear what problem it is or what it is we are supposed to find. The main comment I want to make is about the justification. So when we go to make our justification for normality, it actually turns out that n times p hat is precisely the number of people that said yes in the study. And n times 1 minus p hat is precisely the number of people that said no. So note that this here is actually the number of people in the sample that said yes. And then the other one is the number who said no. So when we do this, instead of finding n times p hat and n times 1 minus p hat and arguing that both of those are 10 or more, what we can instead do is just say that the sample had 10 or more yeses and 10 or more nos. So we can also say the sample had 10 or more yeses and 10 or more no's. So when you go to, if you have a case where you're not allowed to do the confidence interval, it typically will come from there were too few yeses or there were too few no's. So if we had, say, 8 yeses, then we should not run the confidence interval because we do not meet the normality condition. So this is just another way for viewing the normality condition when we are doing a confidence interval and we only know p hat or only know the number of yeses and nos in our sample. Other than that, when we are doing these problems in the future, you don't need to write these two initial statements I've made in the margin of error thing. Really, you just jump to the margin of error. For 95% confidence, we use 1.96. We have different numbers for different confidence levels. So we'll have corresponding numbers that we should use for the different confidence levels. We will see those other confidence intervals in Module 19. Also, for Module 18, feel free to continue using the 2 copies of the standard deviation instead of using 1.96 copies. But 1.96 copies is technically the more precise value. Your homework questions will likely still continue to use the 2 copies of the standard deviation. So this is just my general comments for your finding confidence intervals. Again, in Module 19, we will continue to do the same.